In this example, a ball starts rolling down an inclined plane and accelerates at a rate of negative 1.4 meter per second squared down. And we're asked to find how far does it travel in 5 seconds. It starts rolling down a hill, so therefore its initial velocity is 0. It accelerates at a negative 1.4 meter per second squared, where how far is a question of displacement, and our time is 5 seconds. Looking at our kinematics formula, we know we'll need to use d equals v1t plus 1/2 at squared. Luckily for us, because v1 is 0, this entire term becomes 0. So now our distance, or displacement, is 1/2 negative 1.4 meters per second squared, multiplied by our time of 5 seconds squared. We calculate our value, and our calculator tells us it's negative. We calculate our value, and our calculator tells us it's negative 17.5 meters. Rounding for sig digs and putting in directions, our final answer is 18 meters down. In the second part of this example, we're now asked to find how long does it take for the ball to travel 25 meters. So once again, our initial velocity is 0. It accelerates at negative 1.4 meters per second squared. And we're looking for time. Travel 25 meters is a scalar quantity. The vector quantity of that is the displacement, and it displaces negative 25 meters. Again, looking at our kinematic equation, we know we'll need to use d equals v1t plus 1/2 at squared. Once again, the first term cancels out to 0 because v1 is 0. And if we rearrange for t, t is 2 times d divided by a, square root everything. And if we substitute 2 times negative 25 meters divided by negative 1.4 meters per second squared, don't forget to square root everything. Our calculator tells us it's 5.976 seconds. Rounding for sig digs, it becomes 6.0 seconds. And remember, time is a scalar quantity, so therefore there is no directions involved. For the last sub-question of this example, we're asked to find the velocity of the ball after 8 seconds. So once again, our initial velocity is 0. Acceleration is negative 1.4 meters per second squared. We're looking for final velocity, or v2, and 8 seconds is a measurement of time, 8.0 seconds. Looking at our kinematics equations, we know we'll need to use acceleration is v2 minus v1 divided by t. We're looking for v2, and our v1 is 0. So then to solve for v2, v2 is acceleration multiplied by time, which is negative 1.4 meters per second squared times 8 seconds. Putting that into our calculator, it tells us it's negative 11.2 meter per second. Rounding for sig digs and putting in direction notation, our final answer is 11 meters per second down.